Okay, section 4 of chapter 6, exponents and polynomials, is what we're doing in this entire chapter, and now we're looking at polynomials in several variables, meaning now you can have x's and y's together in the same polynomial. The first set of problems says determine the coefficient of each term, the degree of each term, and the degree of the polynomial. This is very potentially something you could do in your head, remembering that each term is anything separated by a plus. The coefficient is the number in front. The degree of each term is going to be the highest exponent of that term. And the degree of the polynomial is going to be the highest, the degree of each term is going to be the total exponents. And the degree of the polynomial is going to be the highest term's degree. So it's possible to do a lot of this in your head, but it may be just beneficial to go ahead and organize it into a table, just to keep things straight. So you might want to do it like a term, coefficient, and degree table. And every term is separated by a plus, so if you need to plus and then move the minus to a negative here. So we have 12 x to the 4th y, that's the term. That's our first term. The coefficient is going to be the number in front, that's 12. And the degree is going to be the exponents added together. In this case, 4 plus 1 equals 5 on the degree. Next term is going to be your negative 5x cubed y to the 7th. The coefficient is the number in front, including the negative 5. The degree is going to be the exponents of the variables added together. So in this case, 3 plus 7 is equal to 10. Next term is going to be a negative x squared. The coefficient is going to be negative 1. The degree, just plain old x squared, so the degree is just 2. And the last term is just 4. The coefficient is itself, it's 4. The degree, remember, is 0 because it's the same as 4x to the 0. That's equal to 1. X to the 0 is equal to 1. And so the degree of that particular term is 0. And then, of course, when that's all done, you want to find the greatest is the degree of the polynomial. So in this case, 10 is the degree. Because first we're just finding out the degrees of each individual term. Now the degree of the entire polynomial is going to be the largest one of those, and that's 10. Okay. Next we'll evaluate each polynomial for x equals 2 and y equals 3, which means we're going to substitute. So here's our original x squared plus 3xy plus y squared. I'm just going to rewrite it, leaving myself workspace anywhere there's a variable. So for x squared, x is going to be 2 plus 3xy, 3 times 2, y is negative 3 plus y squared, negative 3 squared. From here, watch those negatives, watch your rules, order of operations. 2 squared is 2 times 2, which is 4. 3 times 2 times negative 3 is going to be 6 times negative 3, which is negative 18. And then negative 3 squared, make sure that you're seeing that as negative 3 times itself, times negative 3, and that should convince you that it's a positive 9. And then 4 plus negative 18 is negative 14, plus 9, you should get a negative 5 as your answer.